Static charges are some man-made sources, and few examples we have highlighted here like vinyl binders, equipment covers, plastic document holders, post-it notes, plastic pens, spray bottles, purses, combs, and so on. So why we have highlighted few examples here are few common things which people will have when they are in their workplaces also. So how this is going to affect your work is what we are more concerned with. So you imagine a person sitting on a chair. He may have a tendency to sit and then immediately get up from the chair. That is creating a charge developed in his body, or this activity is creating a charge in his body. So he is statically charged now, and this person will go and touch a device which is a conducting medium. It will suddenly discharge through the device and creates damage to the device. Same way, you may be thinking what comb is having to do with my work area. It's usual practice that people will keep combs in there and they will often comb their hair and all. But when we do that, it is creating some static charge, because when we comb our hair, we can see that there is a charge developed, especially when it is a plastic comb. A charge will be developed in the comb, and unknowingly, if it falls on a device, there is a possibility that this sudden discharge can happen through the device. Same way, plastic spray bottles or purses, all these, when we are keeping all the things away from our work area, the chances of damages are very less. But suppose unknowingly, if these things are very near to the devices which we are working with, there is a possibility that the damage can happen due to electrostatic discharge. So mainly this session is just to create, or I will not tell just, it is to create an awareness among the test engineers especially, but it is holding good to all other categories of people, that this awareness should be there. Since we are in a semiconductor industry, electrostatic discharge can create a lot of damage to our work. So how it is creating damage, to just to get an idea about it, you can see the table shown here and some of the activities which we do daily and how much potential can be developed due to such activities. So we can say just when we walk across a carpet, around 35,000 volts can be developed. Across just sitting and crossing our legs, 300 volts can be developed. Same way when we are working at bench, there are possibilities that we will lift some things which are kept, or if you have a pen in your hand, you keep the pen on the desk or at the workbench and immediately you lift it, the pen carries a static charge now. Now, this pen unknowingly, if it touches a device, there is a possibility that this discharge can occur. So, there is a range given just to show that always 35,000 moles will not be developed. It can start or it can be going to a maximum of 35,000 moles when we do walking across a carpet. Same way, unwinding an adhesive tape. So just to understand this or to demonstrate it, what we can do is just unwind an adhesive tape very fast and keep it near small pieces of paper. You can see that these paper pieces will be jumping towards the tape. So that is what it is showing, that there is a charge developed and it can discharge whenever it gets a discharging medium. So now we move to ESDS, in short, which we call as the electrostatic discharge sensitive devices. So we can define it as the devices that can be easily damaged or that are very much susceptible to electrostatic discharge. A few examples are silicon wafers or dies, packaged ICs, PCB assemblies and components. And not only this much, why we have given these examples are these are the things which we are very often dealing with in our work area, and we have to be careful that such devices are very sensitive, particularly finer geometries are very sensitive to electrostatic discharge. So till now we were talking about failures can be created. Failures can be created in semiconductor devices, especially when they are nanoscale devices. Many failures can happen. So what are the types of failures that can be created due to electrostatic discharge? It is categorized as parametric failure, catastrophic failure, and latent failure. So parametric failure is when a device is exposed to electrostatic discharge and one or more of the parameters, example resistance, is altered, it causing it to shift from its required tolerance. And this failure does not directly pertain to functionality, but it may be present even if the device is still functional. That is the meaning of parametric failure. So next category is catastrophic failure, which is a result when the device is exposed to electrostatic discharge and it no longer works. So here we can understand that the device circuitry is permanently damaged due to ESD. The next category is called as a latent failure, which is the result when the device is exposed to ESD and it is partially damaged, yet it continues to work. The device may have a failure soon in the long run, leading to a reduced life. So the first type of failure, which you have seen as a parametric failure, can be a reason for this latent failure. Like that, you have to relate it because some of the parameters, the tolerance wise, it may be shifted due to ESD, and that may result in a failure for the device in the long run. It may not immediately fail. So what happens here is you may tell it as a very good device, working device, but when it is used in field, one day suddenly it fails. So it is affecting the reliability of that particular device. So always latent failures are very much critical compared to catastrophic failures. So how you can understand here is catastrophic failures can be identified when we test the device because it will no longer work. But latent failures are not like that. Even though there is a failure happened in the device, it still continues to work and it never fails any testing. Only when they use the device in any applications, it will fail in the long run. So this image is giving you an idea about a latent ESD failure. So you call it as walking wounded. The basically how you tell it as the device is already wounded, but still it continues to work. But when you keep on using the device, this wound will become bigger and bigger, and one day finally it will suddenly fail. You can see here the damage shown is like this. Because of this, still the entire circuitry is not damaged and it continues to work, but when you keep on using it, suddenly it will fail. And these two are just to compare the failures, catastrophic failures and latent failure. So catastrophic failure, this is how it is happening. There is a complete cut between the metal trays so that its functionality is fully failed. But in latent failure, you can see the trace, still there is a contact and it will work. But as you keep on using it, it will get separated and suddenly it will fail when we are using it in some applications. But you can note here, both the damages are internal damages, and there are very rare possibility that by seeing a device or seeing a chip, it is possible to identify that there is a failure in the device. So main causes for ESD failures are, since you know the static charge occurrence is happening because there is no path for it to discharge. So the main reason or main causes for these ESD failures will be personal grounding not done, work area not implemented with ESD safety, improper handling and storage and movement of sensitive devices, and wearing static generating clothing, materials and activities in the work area. Now moving on to safety implementation, you can see what all we can do to protect against this electrostatic discharge and thereby the failures occurring due to it. Main thing is personal grounding, reduce the potential for charge buildup. So next one will be ESD safety requirements in the work area, properly grounding all the equipments and the work area and the furniture. Handling and storage of sensitive devices should be done very carefully, and it's always better to highlight what are the do's and don'ts in an ESD safe area. And few examples which will give you an idea, or few materials which are used for ESD safety. Few of you may be familiar with few of the things, few may not be. So I'll just point one by one. First one is wrist strap. Another one is the shielding bag. Next is dissipative shoes. Then you can see anti-static mats, and some of the things are prohibited. So now you may be able to appreciate why these things are prohibited, because these almost all the things shown here I have already shown it as static sources of static charge in the previous slide. So next one is anti-static smoke. So why you tell here, some places you can see there is a term called dissipative. So dissipative is something like in between conductive and insulative materials. So or you may be thinking that when we started we told there is a possibility of charge to get accumulated in a body, and don't think that only insulators the charge will get accumulated, because I have told the main source of static charge is human body, and human body is not an insulator. If so, then we will never get any shock, right? So human body, though it is a conductor, why static charges are developed in our body is, that is where you have to think about. Whenever whatever be the material, whether it is a conductor or an insulator, if it is separated from the ground, or if you have isolated the material from the ground, there is a possibility for charge to get accumulated. And only when there is a path to discharge, that charge will get dissipated. So why we call dissipated material, we will see in the coming slides. So these are few safety materials which we'll be using. One by one we will see in the coming slides. So first one, here you can see they are showing you a wrist strap. The purpose of wrist strap is you will be wearing when you are working with semiconductor devices, or you can say when you're working in a static safe area where static charges can damage or create damage. You are supposed to wear a wrist strap, and the purpose of the wrist strap is to capture the static charge in your body and ground it. You can see there is a plug-in point from the wrist strap. It will be connected to the ground point, so that the charges in our body will be picked up by the wrist strap and it will be grounded, or basically we are grounding ourselves when we are working. Next one is anti-static mats. You can see in the workbenches and all, they'll be using these mats, and this mat, it may be usually of 2 layers or 3 layers. Here what is shown is a 2-layer mat. Here it is, we can say the top layer is a dissipative layer and the bottom layer is conductive. So why you think the bottom is conductive and the top is dissipative? Means there is a difference between the two, right? Dissipative means it has a small resistance, in the sense sudden discharge will never happen. But if it is conductive, we imagine the resistance of a conductor to be 0, right? So there is a possibility of short to be happening that cannot be allowed in a work area. So imagine if you are working on a bench having this mat and the top layer is a conductive layer, whatever PCBs you're placing on it, there can be a short happening between the mat and your working board, right? So to avoid that, always the top layer will be dissipative and the bottom layer will be conductive. And this slide is showing you some of the safety warning labels. It's not that all these labels you can see in one particular place. It will be like any of these labels are pointing you that you are going to enter to a ESD safe area or ESD protected area, and you are supposed to take sufficient precautions before handling such devices or before entering that area. And this is another way of implementing ESD safety in the work area. You can see that the workbench, there is a protective mat. Then you can see there is a plug-in point which will be taking to the ground, so that the wrist strap which you are wearing can be plugged into the ground point, and there is a common ground point. Everything should be connecting to that common ground. And this is another implementation of ESD safety, which is the same way, another interpretation of it. You can just see through. So you have seen there are two things in the safety materials. I have shown you a wrist strap, and another one is a smock, right? So you may be thinking already you are wearing wrist strap, then what is the purpose of wearing these smocks? So the functionality, or what is the function a wrist strap will do, and what a ESD smock will do is different. So you can read this. The wrist strap basically capture the static on your skin surface and connect it to the ground. But what a smog or ESD clothing will do is it will protect the outside world from static charges in your clothes. So when it comes to clothes, we cannot restrict people, you should wear this cloth or that cloth. It is up to their wish, right? But there's people, when they are working, they have to take care that they are not creating any damage to the ESDS things. For that purpose, what we can do is you create a separation between the clothing and the outside world. That's what ESD smog will do. These are some images which will give you an idea how you are supposed to work in a ESD safe area or static safe area. When you work with sensitive devices, you have to wear a wrist strap, and it's not enough you wear a wrist strap, it should be properly connected to the ground point. Same way, how you are going to handle the devices, sensitive devices, how you are going to store the sensitive devices. All these are shown again in the coming slides. You can see some more things, and why these things are restricted already we have covered. Next is ESD safe handling and storage. So till now we were talking about ESD devices. What all will come in that? Already have shown you what are ESDs, or electrostatic discharge sensitive. It can be a chip, it can be an assembled board, it can be a bare PCB also. So why a bare PCB can become an electrostatic discharge sensitive thing? It's because it has traces in it, right? Metal traces in it. So when discharge happens through that, there is a possibility that traces can get damaged. So it's not that only you have to handle the ICs or chips carefully, you have to handle PCBs also very carefully. And you have to take care when you are storing it and when you are moving it from one place to another place. So always wear a grounding wrist strap tightly, and it should be connected to earth ground point. And how you're supposed to handle the PCBs, though it is a bare PCB, you are not supposed to touch everywhere. It's always recommended to handle it by edges so that you are not damaging the conductive parts in it. Handle the components by the edges if it can be handled, if the size allows you to handle it like that. But if it is too small, it's always recommended to handle with any vacuum pen or pickers. You are not allowed to touch the PCB surface on any components and conductive parts with your bare hands. And how you are supposed to store it is, it's a common practice to store ICs, especially ICs in thermocols and all. That is not at all allowed. You are supposed to store it in dissipative static shielded bags or static safe boxes, bins, tubes and holders. Some few examples or few pics are shown here. So the purpose of this shielding bag is whatever is kept inside the bag will be always safe from ESD. Same way, this racks or the boxes, everywhere we can, it's available in the market, how we are supposed to store the static safe devices or sensitive devices. As I told you, this is not at all recommended. You are supposed to put it in proper boxes. And coming to the safety checks, we have talked about some safety materials. One example is a wrist strap, another one is smog. So how you're going to make sure that these things do its work, right? Though you wear a wrist strap, what if the wrist strap is not working? So for that purpose, after wearing the wrist strap, you are supposed to check the wrist strap, and there is a tester which will allow you to tell whether it is working or not. That is what is shown here. And same way you can see this is showing you, this image is showing you how you are supposed to check the ESD shoes. So what is this purpose of this ESD shoe is just the opposite of the normal shoes which we wear. So when we started, I've told you static charge can be accumulated when we walk on a floor, right? So that when we walk on a floor is not enough. When we walk on a carpet after wearing shoe, there is more possibility of static charge accumulation. So that shoe and the shoe are different. This is a conducting, or you can say a dissipative shoe, which will not allow static charge to get generated in your body. So that also should be checked. And you can say if it is working, then only you are supposed to enter the test floor or static safe areas. So for our test lab, test floor, we have three test floors. In the sense, two test floors and reliability lab. All the three entrance, you can see these testers are there. You are supposed to test it. If it is not working, you have to inform the concerned person and exchange your wrist strap and your schmuck or the shoes. And what is this image showing you is, as I've told you, this usually static safe materials will be dissipative. So even though the wrist strap purpose is to ground your body, it should not suddenly discharge, right? Then it may create harm to yourself. For that, they will include a resistor in the wrist strap, and usually the value of that resistor will be 1 mega ohm. So that is what it is showing you. You can, when you measure the resistance of the wrist strap, usually it will show you a value of 1 mega ohm. Now coming to the do's and don'ts, it is just a summary of whatever we have covered. What are the do's in an ESD safe work area? Keep work area dust free, clean and neat. Wear grounding wrist strap while handling PCBs and components. Hold PCBs by their edges only without touching any conductive parts. Handle semiconductor parts using vacuum pen or picker. Use ESD safe bags, boxes, bins, and trays for storing PCBs and components. Wrist strap and ESD shoes should be checked on a daily basis before entering ESD areas, and the same should be locked. So this is very important. The last point is very important. Again, I will be stressing at the same point, the wrist strap and the ESD shoes, which will be given as a personal thing for you, should be checked on a daily basis before entering ESD's area, and the same should be logged. And what are the don'ts in ESD safe work area will be: do not allow food and drink in the lab, do not store PCBs in plastic or polythene bags, do not stack PCB one over the other or without ESD safe bags, and don't store components on thermocol sheets or polythene bags. Do not use moisturizing creams and lotions containing silicone on hands. So these are the main do's and don'ts which we have to take care in an ESD safe work area. So that's all. Thank you for your time.
Yeah, hi all. So this we have completed with this the ESD session. So I think who has recorded this thing? I don't know why. Who has given a recording? So please do not record this. I don't know who has started recording this one. So please do not record all these sessions. So I request Danya, are you there, Danya?
Yes.
Yeah, if anybody has any questions, you please ask Danya. She will clarify your doubts. I think no one has any doubts. Is that very clear to everyone? Okay. Okay, in that case, thank you all for attending this session. And we are going to conduct an exam for this, where we will be sharing a questionnaire to you through the forms, and you will have to fill this answers and you have to submit it. And with this only, you will be completing your ESD training. So if anybody scores less than the qualifying marks, they will have to undergo the retraining, and we will let you know if somebody scores very less. So, so is there any doubts anybody has something like that you can discuss here, else we can close this session. And also we will be submitting your attendance in the TMS tool. You will have to fill the feedback for this ESD training, all the participants. Yeah, that's all I think. Danya, no one has a questions. Danya, thank you.
Yeah,
So with this we are going to end this session. Thank you all. Thank you.
thank you.